Hello everyone, I'm Karthik Gurjar. Today I am presenting part B of our internal test analysis on group data and correlation submitted to Dr. Shaligram Prajapat. I will walk you through the solutions for question 3 and 4, covering everything from median calculations to visualizing student productivity trends. Moving on to the first slide. Question number three, group data analysis. Let's start with question three. Where we need to find the median satisfaction score for student lab infrastructure. If you look at the data distribution, you will notice that the 21 to 50 score range contains 1500 students. This is the largest group by far, which gives us a strong indication that our median value lies somewhere within the specific interval. Finding the median. There are three steps. To confirm this mathematically, we first found the total number of students, which is 3,194. Since the median is the middle value, we divide this by 2 to get position 1597. When we sum the students in the first three groups, we get 950. Adding the next group brings us to 2450. Since 1597 falls right between these totals, we confirm the median is definitely in the 21 to 50 range. Calculating the exact median. Now, to get the exact number, we use the interpolation formula for group data. We applied the lower boundary of 20.5 and a class width of 30 based on the cumulative frequency calculation. We added approximately 12.9 to the base. This gave us a final calculated median satisfaction scores of 33.4. Moving on to the next question. Moving on to the next question, age versus productivity. In question number 4, we analyze the relationship between age and learning productivity of a group of 18 students. Our goal was to calculate the key statistics like mean, median, and standard deviation, and then generate three specific types of plot to visualize the spread, correlation, and normality of data. Statistical summary. Looking at the statistical summary, the data tells an interesting story. For age, the mean is 46.4 years with a high standard deviation of 13.2, indicating every wide age range in our sample. For productivity, the mean is 28.8% with with a much lower deviation. Interestingly, both medians are slightly higher than their means, showing showing a slightly skew in the data. Visualizing relationship. To visualize this, we used three techniques: box plot to see the spread, scatter plot to check for correlation, and quartile plot to test if the data follows a normal distribution. Box plot. The box plot highlights a clear contrast between the two variables. The age box plot is tall, visually confirming the high variation we just discussed. On the other hand, the productivity box plot is much narrower, showing the productivity scores were far more consistent across the group than their ages were. Scatter plots, correlation scatter plots. Next, the scatter plot places age on the x-axis and productivity on the y-axis. You can see the box plot drift upward as you move to the right. This shows a moderate positive correlation essentially in this specific sample. The older student tended to report slightly higher productivity levels. Normality. Finally, we looked at the quartile plot to check for normality. The data points track the diagonal line in the center but deviates noticeably to the at the tails. This implies that while our data is roughly normal, it is not perfectly so, which is an important consideration for further statistical testing. Thank you for your time. I'm now happy to answer any questions you might have.